to take a look at what we've been doing here, we've looked at logic and a subsection. If logic is considered to be just reasoning, then a subsection of that would be deduction. And a subsection of deductive logic would be propositional logic. So we'll take a while before we get into categorical logic. So right now we're talking about propositional logic. Within propositional logic, you have the idea of validity versus truth versus sound. So for example, an argument, if you were to consider an argument, it might have some truth value to it. So for example, if you just take the basic idea and the basic understanding that my ink is black and my paper is white, those might be true things. But of course I could always misconstrue how I use that information. So to talk about the truth of something, this one is really hard to nail down and define, because you're trying to indicate, well, what is the truth value of something? So is it true or not true, which we'll call false by our laws of logic. So either a statement has a true value or a false value. Okay? Now, to talk about validity, if an argument is going to be valid, then the structure of it needs to be correct. So it has nothing to do with the truth or falsity of the given argument. For example, if A, then B, and if B, then C, therefore, if A, then C. This is a structure here that I just drew up. This would be a valid argument. Why is this valid? Because A leads you to B, B leads you to C. So therefore, A led you to C. So that is why this happens to be a valid argument. Now, if A is false and C is true, nothing in here really matters in terms of true and false. But the argument is still a valid argument, even though the truth value of those statements might be true or false. It might, I mean, who knows what could happen with the individual value of that. But so validity, talking about whether or not an argument or a string of arguments is valid or not, validity is measuring if the structure works or does not. It doesn't actually tell you anything about whether it's true or false in the end. It's just telling you, hey, this structure is correct. This structure is a valid argument. Now you independently would then have to go and check the individual truth or false values of A, B, and C to be able to determine what the meaning is behind each of these. So then, given that an argument is valid and also true, both of those together are what we call a sound argument. It holds, not only does the structure hold, but it happens to give you a conclusion that is true, a true conclusion. It gives you something that's actually meaningful at the end. So that is called a sound argument. All right, so let's look at some examples of arguments. So let's consider that all dogs are mammals. So if it is a dog, then it is a mammal. All terriers are mammals. So if it is a terrier, then it is a mammal. And the conclusion being all terriers are dogs. So if it's a terrier, then it's a dog. So can we validly conclude that? So let's test whether or not these things are true. Is it true that if something is a dog, it is a mammal? Yes, dogs fall into the category of mammals. Is it true that a terrier is also a mammal? Yes, that is true. So let's test. We know that this is true. And what we're going to test is this conclusion that we come to, and these three dots here just indicate therefore. So this is our conclusion. That's what that's indicating. It's telling you this is the concluding statement. It tells you therefore all terriers imply, so if it's a terrier, then it is a dog. Okay. To construct this together, you can only take from what's on the left-hand side to the right-hand side, and then you can only match it up that way. So for example, if it's a dog, it's connected to mammals. So a dog on the left-hand side connects to mammals on the right-hand side. So in order to connect that to the terriers here, I would need mammals to actually be on the left-hand side so that I could connect dog to mammal and then mammal to terrier. But I can't do that because mammals is actually on the right side. It's not on the left. I can't pick this up and string it over here because it doesn't say anything about that just yet. And we'll get to those more complicated functions dealing with the reasoning and being able to change it up and switch it around and manipulate them. We'll deal with that a bit later. So right now, this just says that dogs are mammals, terriers are mammals, and it doesn't allow you to conclude anything about terriers and dogs, just terriers and mammals and dogs and mammals. So this is invalid. It might be true. It might be true. So for example, are terriers dogs? Well, yes. So it is true, but this is not a sound argument because it's invalid. The structure is broken. It doesn't actually connect. So it's invalid because the structure doesn't work. Let's try another one. So let's say all dogs, if it's a dog, then it's a mammal. So all dogs are mammals. All cats are mammals. So this is the same structure as before, but can we connect cats and dogs? Can we say that all dogs are cats or all cats are dogs? We can't. So to conclude that if it's a cat, then it's a dog, to conclude that would be invalid. Whether or not the conclusion is true or false doesn't matter. It's an invalid argument. The structure is wrong. So validity, remember, to be valid, you must look at the structure, the logical structure.